Hey guys, how you doing? Hey, incidentally, it's January 22nd. It's Sunday. It's after third service here in California, and this is John Saddis. And I want to say thank you to Kevin Walding for bringing up a great idea. I was supposed to meet him here this morning, and he happened to have the video camera. So, Michael, God bless you and everything, the effort that you're doing down there. And this particular recording can go specifically to CJ. Hello, CJ. What I'm showing here is the plan set, of which is going to be the instructions for the continuation, for the building of the church. Now, previously I gave this particular set to, not the whole set, but the page that you're looking at right now. It has the leach field right here. Let me zoom on that. Okay, that's the leach field. And as I continue through the lines of the leach field, it goes into the bathrooms. There's the backstage area. This is the north area right there. It says main highway beyond. Well, that's the property line there. And as we go down, those are the numbers that Mike gave me. That is the northeast corner. Then it goes down towards the southeast side, which is right there. And I have the arrow here instructing where north is, of course. So let's go back to the leach field. Now, this is pretty much the layout for the distribution of all the waste that the church is going to be accumulating in the time that the congregants get together and use this thing. Now, I'm going to try to condense as much as I can, but at the same time explain how we need to proceed with this project, okay? My recommendation would be first to establish the building lines, and then from the building lines, which is like this corner here, where the bathrooms are, and then you'll go up to the north, that corner there, and then of course you're going to go to the east, that corner, and you're going to go down, and there's the main entrance, and then you're going to go down to the southeast corner. Now, establish those lines first. Once you have those established, also just to make a general note, we want to be 5 feet minimum from the property lines. In other words, here's the property line. Here's the property line here where my finger is. So we want to start the building right about here, 5 feet. And then when I drew these plans, I didn't have these exact property measurements. So I was just kind of going on the fly, but now that I have them, those numbers can be established in this instruction video, okay? So we have the building lines established where we need to go. We have his bathroom, her bathroom, and then this is a solid line, CJ. It says here, solid 4-inch sewer line. That'll go into what we call a proposed septic tank, clean out solids. I have details on the other sheet below this one that shows how this thing should be constructed. Now, it's primarily concrete. This is section 1, section 3, section 2, and section 4. Section 1 and 2 will be constructed first. Then section 3 and section 4 will be constructed second. That detail is on sheet 2. Now, after the main septic tank for the cleanout is built, the lines are going to continue as a solid line, and then they're going to go into what we call the distribution center or box. There's 3 outlets here, here, and here. That, if I zoom out now to the whole layout of the leach field, you'll see that it's 50 feet long by 20 feet wide. There's 3 of them in between. Here are your measurements. You'll see those on the plan that you have, that Mike has. It shows that the width of each leach field is, each leach dig out is 24 inches wide, and then it goes to 6 feet wide between each leach dig out. Okay? You'll see that on the plan you got. So the distance between here, which is the building perimeter of the southeast corner, to the edge of the first leach dig out, that is what's on the plan is not going to be the distance it is. It's going to be more now. Now that we know, if you look down here where the property line is, we have quite a bit. This is scaled out in 3/16 inches equals a foot. So we'll probably be able to move this whole leach field more down towards the property line. If I'm to come back a little bit, if you notice the property lines, there's a parabolic to my right. It's parabolic in the right corner. And so if we were to take that leach field and move it down 5 feet from the property line setback, then I think we'll have more area where cars can park and the leach field can be built. And I want to make a very, very important note here. When this leach field is established, we do not want to, and you probably know this, we do not want to use it for planting anything, to stage anything, to park cars over, to pour concrete over. It's forever and ever a leach field, and it should be established as that forever and ever for the course of the life of the church. Okay? So that's the note that has to be taken into consideration and maintained as a rule for the congregation. I mean, for just the administration, to never do anything, to stage anything, pour concrete, park, plant any kind of food or anything like that, and no well water or anything like that. So that's that. Okay, so we have pretty much an idea what the established perimeter of the building is in relationship to the property lines, and then we also have an idea where the leach field will be finally installed in relationship to the property lines down on the southeast corner. Now I'm going to turn the page to the foundation plan, and this is where we really need to pay attention here. I'm really glad this is helping out. I'm glad that Kevin brought this up, this idea up, because it's going to help you guys kind of understand just about how this building should be built, okay, from the ground up. Now, I'm going to zoom out. Now, try to follow me the best you can. I'm going to zoom in a minute here, but let's just try to do the best we can. Where my finger is, if I take my finger, I'm going to my right now, and I go to this corner here, this is the east end of the building. There's the door, the main entry right there, okay? Now, I'm going to go to this grid here, and that grid line is called B, grid line B, and I'm going to jump another area, and that's grid line A. Now, if I follow that grid line A all the way up to the west corner, or west end of the building, I'm going to find right there, I'm going to zoom into you now, that little square thing, it's not noted here, but it is going to be noted later. That's actually a post. Remember the email you sent me where we were trying to decide what the country uses as far as any support post? Well, I talked to Scott, who's been down there several times, and he spoke with David Eastman, and Eastman said that what Nicaragua does for any sort of structural load path or post is they take C-channels, probably about 2 inches wide, maybe 3 inches long, 2 inches thick, 3 inches wide, maybe a wall thickness of about 3/16 or maybe an 1/8 inch thick, and they seam weld them down the whole length of the C-channels. So, and they come in lengths of 18 meters, which calculates out to 59 feet, American feet. Now, their little square that I'm pointing at is just one of those C-channels, okay, that have been seam welded together. Here's one, here's one, here's one, here's one, here's one, here's one. This is actually the mirror image of the main entry side. Why? Because we have to be consistent with our grid lines, because within the perimeter, now here, if I go here again, from this corner to this corner to this corner to that corner, within inside these wall perimeters, I'm going to zoom in. You see that? That's a pad footing. Directly across on grid line B is another pad footing. I've made a note here. It says pad footings, they're typical. So the dimensions aren't here, but I'm going to put them on there later. So anyway, you got pad footing here, 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 and then you got the walls. Now, they're 20 feet apart. Here's your number, 20 feet to the center. Same here on this side, center to center. What these posts are going to do, CJ, they're going to be the posts that are going to carry the load for what we call the purlin, that are going to be mid-span of the roof rafters. The roof rafters from the connection of the ridge to the eave end, they're going to be about 30 feet long. So we don't have any deflection. We need to control the fugitive weight, live weight, that's going to be up there by supporting them with these posts. So this post, this post, this post, this post, and so forth are going to be erected up to the bottom, and I'm going to show you another page of the continuous purlin that's going to run this way, that are going to be mid-span of the roof rafters. Now, they're calculated because of the distance of the whole building. So here again, I'm 100 feet. Right here, it's 100 feet is the length of this building by 52 feet wide. Now, with that sort of a diaphragm, it's necessary that we put these pad footings in place, because the weight that they're going to be carrying are only going to be the weight of the roof rafters and the weight of the corrugated metal, and probably the weight of maybe a couple guys at a time to systematically begin where it's comfortable for them to start putting their corrugated metal to the middle of the ridge and out, and then start placing their corrugated metal roof systems on top of the rafters. So these posts will hold their weight, but they need to seam weld those things together and then cut them to the height that's necessary. Now, from the top of the ridge, I'm going to show you that in a minute on another page. From the top of the ridge of this church building, it's 20 feet from the top of the ridge all the way to the top of grade. All right, so that means that the walls, using a 412 pitch roof, are 10 feet 6 high. So that being the case, I'm going to show you some information here on the next page. We have to maintain these pad footings in place where they're calculated to be. Okay, this is a detail 7. It'll be on the next page. I haven't put the page number yet, but that's detail 7. All of these pad footings will follow suit of detail 7. Detail 1 will be detail 1, which is I'm going to show you right now. It's on this page here. I'm going to shoot it over to this detail right here. So here you have 36-inch footing. Here's the anticipated proposed 4-inch concrete slab. You have 6 mil plastic over 2 inches of sand. That's how we do it here. Hopefully there'll be enough in a budget to do that with them. If not, that's okay. Just go ahead and pour the mud on top of their grade. And then we have our footing here. The footing has to be 36 inches wide by 18 inches high, deep. Now, normally, I know you know this, we want to create a bond beam. So when we pour the first course, we want to make sure we pour it into the footing, right? Then we want to try to bring the bond beam, in this particular case, because it's a 10-foot high wall, to 3 feet high. Now, when we make our hook, this is a 5/8 piece of rebar, 5/8 rebar at 32 inches on center inside the sails of this thing. Now, when we place this in here, it's going to go down into the bottom of the footing and then hook all the way over towards the whole length, the width of the footing. Now, you have to make sure that you protrude this thing 20 inches out, because I must shoot over here to the section drawing. You see the section drawing here? It's the same conditions. Here's a 36-inch high bond beam, but then notice I've spliced another 5/8 rebar verticals all the way up. Okay? You'll see that right verticals. Now, it says here 5/8 rebar at 32 inch on center, verticals Splice 20 inches to bond beam.